for sanitation and hygiene, waste management, water management, energy management, green by Mahatma Gandhi National Council for Rural Education, Ministry of Education, Government of India. Also, our strive towards excellence is being appreciated and honored. To mark our efforts, college was awarded as a model engineering college placed in northern part of Karnataka by Vishveshwaraya Technological University, Belagavi. Brief introduction about our department. The Department of Mathematics was established in the year 2008 to cater to the needs of different engineering branches. We have a young and enthusiastic faculty involved in the teaching mathematics. Mathematics is the backbone of all engineering sciences. Hence, a lot of stress is given on mathematics in engineering education. Engineering mathematics is taught at first 4 semester of BE degree courses. The staff of the department are actively participating also in teaching interdisciplinary courses. In terms of results, our department is doing well. BTU January 2020 first semester exam, 4 students scored 100 out of 100 and 58 students scored more than 90 marks. And for the third semester, 35 students scored 90 above marks and 3 students scored 100 out of 100. This is brief introduction about our department. Next, brief introduction about Srinivas Ramanujan. Srinivas Ramanujan was born on December 22, 1887 in the town of Erode in Tamil Nadu. His father was K. Srinivas Iyengar. His family was very poor. At the age of 10, Ramanujan was the top student in his district. National Mathematics Day is celebrated every year on the December 22, honoring the birth anniversary of mathematical genius Srinivas Ramanujan. In 1918, Ramanujan became the first Indian mathematician to be elected a Fellow of British Royal Society. In his short lifetime, he produced almost 4,000 proofs, identities, and equations in pure mathematics. Before he died at the age of just 32 from tuberculosis, he had already given the world around 3,500 mathematical formula that scientists have still not been able to completely prove. This is the brief biography of Srinivas Ramanujan. To know more about Ramanujan, please do watch the movie The Man Who Knew Infinity. This is brief introduction about Srinivas Ramanujan. Now I would like to request Professor Sachin Mekkalake, Head of the Department of Mathematics, KLECET Chikodi, to present a welcome note for today's function.
As rightly quoted in Rigveda, Yatha Shika Mayuranam Naganam Manoyata Tadvedanga Shastranam Ganita Murdani Sitam. As the crests on heads of peacock, as the gems on hoods of serpents, so mathematics is the helm of all sciences. In 2012, on the eve of 125th birth anniversary of Srinivas Ramanujan, former Prime Minister Dr. Manmohan Singh declared December 22 as National Mathematics Day in India. 2012 onwards, National Mathematics Day is celebrated every year. The main objective behind the celebration is to raise the awareness among people about the importance of mathematics for the development of humanity. Due to pandemic COVID-19, this year we have organized webinar and online hands-on training on GeoGebra. Today we have the resource person, a humble teacher, Dr. S.S. Benchalli, Professor and Head, Department of Mathematics, BC Bagalkot. I welcome you to this webinar, sir. Welcome, sir. I welcome our beloved principal, President of today's webinar, Dr. Prasad Rampure, sir. Welcome you, sir. I welcome Academic Coordinator, Professor Satish Bhojanavar, sir. Welcome you, sir. And I also welcome First Year Coordinator, Dr. R.K. Patil, sir. I welcome HOD of Civil Department, Pradeep Hodlur, sir. I welcome Head of Mechanical Department, Professor Kumar Chawla, sir. Welcome you, sir. So I welcome all faculties of basic science departments. I welcome all students, faculties of various colleges to this webinar. Once again, welcome you all. Thank you.
Thank you, sir. Now, I would like to request our beloved principal, academic coordinator, HODs to perform a photo puja.
What? Photo group. Just. Okay.
Dear students, I think this is the first interaction with you all. So I'll not talk much because there is a guest who is going to speak, Professor Benchalli. But before that, what I would like to tell you is, normally everybody gets frightened of mathematics. But if you start loving mathematics, nothing like it. Okay. So instead of getting frightened, you try to devise certain things wherein even mathematics becomes easy. So when you start loving mathematics, automatically you will feel at ease. So Professor Benchalli is there with us now. He will be talking about the topic. And once he finishes, then maybe I'll talk to you after that. Thank you.
Thank you, sir.
Thank you, sir, for your valuable words. Now, I would like to request Professor Vinayak Patil, Department of Mathematics, KLECET Chikodi, to introduce our chief guest.
Good morning, everyone. morning, everyone. Success is not an accident. It is a hard work, perseverance, learning, studying, sacrificing, and most of all, love of what you are doing or learning to do. So it's my privilege to introduce our chief guest and research person, Dr. S.S. Benchalli. Sir has completed his PGDCP in computer languages in 1988 from Karnataka University, Dharwad. Sir has completed his master in mathematics from Karnataka University in 1990. Sir has pursued his master in philosophy from Karnataka University in 1998. Sir has pursued his PhD from Karnataka University in 2006. Now, we will move to the Sir's professional experience. Sir has worked as a programmer from 1989 to 1990 in Microfinish Pumps Private Limited, Hubli. From 1990 to 1997, Sir has worked as lecturer in Jobin Science College, Hubli. From 1997 to 2002, Sir moved to Bashveshwar Engineering College, Bagalkot. And in the same college, Sir has worked as senior grade lecturer from 2002 to 2006. Further, Sir worked as an associate professor and head of the department from 2006 to 2018. Presently, Sir is working as professor and head of the department in Bashveshwara Engineering College, Bagalkot. Now, we'll have look on Sir's area of research. Sir has done his PhD with the thesis titled Computations of Effect of Rough Surface on Lubrication Characteristics with Applications in Tribology. Sir has done his MPhil, the dissertation titled on Fractals, Computation and Applications. Sir has interest in numerous mathematical areas like numerical analysis, fluid dynamics, fractal geometry, complex analysis, computer science, and GeoGebra. Sir has published 11 national and international research articles. Sir has attended 24 national international conferences, national seminars, and workshops. Apart from this, Sir is also a live member of ISTE New Delhi since 1998. Also, Sir is a live member of Karnataka Rajya Vigyan Parishad since 2005. Also, Sir has created various applets and uploaded in the GeoGebra website. Sir has created YouTube channel DEC Mat 16 for engineering students. Sir has given more than 26 talks on GeoGebra and mathematics. Sir has served as member of BOA for 5 times. Since Sir is also a member of VTU Doctoral Committee. For the academic year 2008-9 and 2012-13, Sir has served as a BOE member, Mathematics Board, VTU Belgaum. Also, for the academic year 2015-16, Sir has served as a BOS member, Computer Science and Engineering, BEC Bagalkot. Also, Sir has designed and successfully implemented syllabus for mathematical modeling as an open elective subject for 6th and 7th semester BE course from the academic year 2011 onwards. With this brief introduction, I present a great personality before you, Dr. S.S. Benchalli. Once again, I welcome you, sir. Thank you one and all.
Thank you, sir. Now, I would like to request today's resource person, Dr. S.S. Benchalli, to start the session. Sir, please start the session. Over to you, sir.
Hello. Sir, you are not audible, sir. Sir, ನೀವು ಮ್ಯೂಟ್ ಇದ್ದೀರಿ, ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊರಿ ಸರ್. ಹಲೋ ಸರ್. ಹಲೋ. ಸರ್, ನೀವು ಮ್ಯೂಟ್ ಇದ್ದೀರಿ. ಹಲೋ.
Benchalli sir. ಹೇಳತ್ತಾರ ಏನು ಬಟ್ ಅವ್ರಿಗೆ ಅದನ್ನ ಅನ್ಮ್ಯೂಟ್ ಐತೆ ಅನ್ಸುತ್ತೆ. ಕಾಲ್ ಮಾಡ್ತೇವೆ ನೋಡ್ರಿ ಸರ್, ಚಂದ್ರ ಗೊತ್ತಾಗತ್ರಿ.
ಹಲೋ ಸರ್, ನಿಮ್ದು ಮ್ಯೂಟ್ ಇದೆ, ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊರಿ ಸರ್, ನಿಮ್ದು ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ.
ಅಲ್ಲಿ ಕ್ಯಾಮರಾ ನೋಡ್ಕೊತೀವಿ.
So dear participants, wait for 2 minutes. We'll communicate with the sir. Okay, join away.
Sir, am I audible?
Sir.
Yes, sir, you are audible, sir, now.
Okay, thank you, sir.
Please,
Sorry.
please go. No problem, sir. Go
Please
ahead.
start the session, sir.
Sir, I think a screen is visible.
Yes, sir.
Yes, sir.
Okay. So first, I would like to thank for the opportunity and thanks for nice words about me. And I would like to welcome all the first year engineering students to engineering family. I want to congratulate all the students for selecting engineering course because it is a very good course. You can make a bright career in this course. Okay. Next point is I wish you all happy National Mathematics Day. I am very happy to see the program since from last 2 to 3 minutes. I enjoyed each and every session. So I want to begin my talk with a quote: "Past is experience, present is experiment, and future is expectation." Now I would like to say that all the students can use your experience. Use your experience means whatever efforts you have put to complete your PUC. right? Now you are going to conduct an experiment. How many years? Next 4 years. It is an experiment, right? Suppose if you put lots of effort in the next 4 years, I hope your future will be very bright, right? Now you can set your experiment. Now you can set your experiment. After 4 years, I want to be a software engineer in the best company, right? Now you can set as an experiment. After 4 years, I want to be in MIT, Manchester Institute of Technology, for higher study. It means if you want to go for higher study, you can go for higher study. Is it clear? In that sense, I can say that next 4 year is your experiment. If you work hard in the next 4 years, then only your future will be very bright. Am I right? Okay. I wanted to share one more important quote. True guidance can be a small lamp in a tunnel. It does not show everything at once, but it gives enough light for next step to be safe and sure. Whenever we want to move in a tunnel, light is required. Is it clear? Right? I hope it is understood. I don't want to elaborate. Right? Okay. Now I wanted to talk about GeoGebra. So before talking about GeoGebra, you may ask, I have joined for engineering course. Why I want to study GeoGebra? Not only GeoGebra, right? You may ask why we want to study a tool like GeoGebra or Scilab or MATLAB or any other tool. Answer is very simple. Suppose if you want to calculate what is the volume of a matchbox. Is it clear? Matchbox is a open top box. When you open the box, no, you can see open top box. You want to calculate volume of the matchbox, right? Okay, you can calculate length is known, breadth is known, height is known. Is it clear? Right? So by using length, breadth, height, you are able to calculate volume of the matchbox, right? Okay. Now I will ask you to calculate what is the volume of the dome, what you are seeing on the screen, right? So volume of the Gol Gumbaz dome. It is a very famous Gol Gumbaz, no? Right? So now you want to calculate volume of the dome. How you are going to calculate volume of the dome, right? I cannot calculate volume of the dome using length, breadth, height. Is it clear? Right? So it is an engineering problem. Now, in the next 4 years, you are going to study this type of problems, right? So to solve this type of problems or to analyze this type of problems, we need the help of tools like GeoGebra, right? Or MATLAB or any other tool. Is it clear? Okay. What is the goal of this lecture? This lecture is designed to familiarize GeoGebra. I am talking only about GeoGebra, right? Okay. After 1 hour, you may be able to use GeoGebra, right? So why you want to study GeoGebra, or what are the objectives of this lecture? To enhance teaching and learning of mathematics, right? Not only you, teachers can also enhance their teaching as well as learning of mathematics with the help of GeoGebra, right? To move students towards higher levels of understanding. Now you can understand mathematics, right? Suppose if you want to understand mathematics in a better way, for that reason, you need the help of tools like GeoGebra to develop students' understanding, stimulate their interest, and increase their proficiency in mathematics. We need the help of GeoGebra. These are the objectives of this talk, right? Okay. Now I am showing a photograph of a Swamiji, Siddhaganga Swamiji, right? So it is enough to introduce SIT Swamiji or Siddhaganga Institute Swamiji. Is it clear? Right? So what I wanted to say that a picture says more than 1,000 words. One picture is equivalent to 1,000 words, right? And a dynamical animation says more than 1,000 pictures. One dynamical animation is equivalent to 1,000 pictures. In GeoGebra, we are going to demonstrate mathematical concepts. That's why GeoGebra or any other tools plays an important role. Is it clear? Okay. Now, who is the creator of GeoGebra? Right? I am using GeoGebra, but who is the creator of GeoGebra? I should know. Right? So, GeoGebra developed for mathematics learning and teaching in schools as well as colleges by Marcus Hanenwarter. Right? I hope you are seeing his photograph at Florida Atlantic University. He is the creator of GeoGebra. Right? Okay. Then you may ask, what is GeoGebra? So GeoGebra comes from combining the words geometry and algebra, right? So we are already familiar with geometry. We are already familiar with algebra. Now you want to study what are the properties of geometry, what are the properties of algebra. When we are going to combine these two, what are the properties I can study? That itself is the GeoGebra. So Marcus, what he collected, I think 3 characters from geometry, right? 1, 2, 3, 4, 5 characters from algebra. GEO, GEBRA, right? GEO from geometry, GEBRA from algebra. Then he combined the word GeoGebra. Is it clear? So GeoGebra is a tool that will graphically demonstrate and help teach the concepts of geometry and algebra. It will provide connections between them, right? So GeoGebra is easy to learn and use, right? Okay. So it can be downloaded from this website, and it is a multi-platform. It can be installed either in Windows or Linux, etc., etc. Right? Okay. So this will be a hands-on demonstration of how to use GeoGebra as a tool to teach concepts in algebra, geometry, as well as calculus. Right? So GeoGebra is a dynamic geometry system. We can do constructions with points, vectors, segments, lines, conic sections, as well as functions, and change them dynamically afterwards. Is it clear? Okay. On the other hand, equations, coordinates can be entered directly. Suppose I will ask you, what is the geometrical meaning of y is equal to mx plus c? So you may say that equation of a straight line. So like that, you can enter any equation. What is the geometrical meaning of that equation? X square plus a square is equal to a square, right? Like that, you can enter any equation directly. It will give automatically the diagram of the equation, right? So GeoGebra has the ability to deal with variables for numbers, factors, and points, find derivatives, integrals of functions, etc. Directly you can find out factors, right? So derivatives, integrals, etc. You will come to know within a 5 minutes. Okay. When you are going to open the GeoGebra, what is the front face, right? So front window or front face looks like this. Is it clear? Right? So this area is called a drawing pad, right? And I hope you are observing input. So this box is called plus side, one box is there, no? Right? So input box. So you can type your equations here. I can type y is equal to mx plus c. Immediately I will get a straight line. Or I will type y is equal to x square. You will get a parabolic curve. Like that, you can enter any equation in input box, right? Okay. Whatever diagram I will get now, corresponding algebraic information will be available in this window. That's why it is called algebra window. So these are the main menu. Whenever you want to draw a particular diagram, just you can click and drag, draw the diagram. I will show you, right, how you are going to draw the diagram, right? So this is the inbuilt keyboard, right? It means when you are going to open a first page, it looks like this. Okay, right? So what are the advantages of GeoGebra? Easy to learn. It is a self-learning tool, right? Allow students investigation of properties in geometry. You can study various properties in geometry. Allow student investigations of properties of algebraic equations, right? So for example, you can write down y is equal to mx plus c. If c is equal to 5, what type of straight line I may obtain, right? If c is equal to minus 6, c can be replaced by various numbers. Then you can observe the corresponding diagrams, right? So like that, you can learn lots of properties about the equation, about algebraic equation, about the diagram. Is it clear? It is just like a game. By playing with GeoGebra, we can learn lot of things. Is it clear? And you can create animations. Animations means, say for example, y is equal to 4x. You can draw the diagram of 4x or 4x square. Is it clear? So in general, if I write y is equal to small a is an arbitrary number. A into x square. A can be replaced by 1, 2, 3, 4, 5. Right? I don't want to replace repeatedly. Is it clear? Right? Automatically, I can change the values of A. A can be replaced by 1 to 5 or in between minus 5 to plus 5. What type of diagrams I can obtain? Now I want to draw a family of curves. Is it clear? Such things can be created very easily. That is important. Is it clear? Right? Such things are available in GeoGebra. So these are the advantages. Right? So decide at what level the use of mobiles or computers should be taught. It means I cannot say that GeoGebra will do each and everything. It means I cannot learn each and everything. Each and everything means all the mathematics from GeoGebra only. Is it clear? Right? So it is a tool. So remember, it is not the complete mathematics. It is a tool. So these limitations we must know. Right? Okay. Now I will begin a activity. I am going to demonstrate. Suppose if you want to change the scale of x-axis or y-axis, how we are going to change the scales of x and y-axis, I am going to demonstrate, right? So now I will open a GeoGebra. I hope screen is visible. Now all of you are observing a GeoGebra screen, right? So now the scale is 0, 1, 2, 3 and so on, right? So now I am moving graphic pad, right? So like that you can move a graphic pad. Is it clear? Now I want to change the scale, right? Now I want to change the scale. Is it clear? So I am using a mouse, right? Using a mouse, you can roll. Is it clear? Right? So like that, you can change the scale. Now 0, 0.2, 0.4, 0.8 and so on. Am I right? Okay. So like that, you can change the scale of x and y axis. This is the first activity. Okay. Right? As I have mentioned, algebraic window, you can input, you can type any equation. I will type y is equal to x. Right? I hope all of you are observing a straight line. Like that, you can enter any equation. Is it clear? Right? So then here they have written a pen. I will select this pen. Right? So I can write down anything on the graphic pad. Right? Okay. Now I am going to write down any words. Right? ALECET. See, KLECET, Chikodi, right? Like that, you can write down anything. Is it clear? I hope it is very simple. And one more thing they have written, freehand shape, right? So just a minute. I will remove this one to avoid the confusion. I will not store this one. Okay. Once again, I am going to select freehand shape. Suppose I want to draw a circle, right? What I will do, I will draw a circle like this, right? So you can draw a circle, right? With the help of a freehand pen. Now I want to draw a square. I will draw a square. It is not a square, right? Like that you can draw any diagram. If you want to draw a triangle, okay, you can draw a freehand diagrams like this, right? Yes, circle like that. You can draw. Yes, you can draw diagrams like this. Okay, I have drawn some diagrams like that. You can practice afterwards, right? So you can see the algebraic window. Whenever I will draw a diagram, no, you can see the corresponding algebraic information about the diagrams. No, I have not typed any one of these things. Is it clear? Automatically, it will give information about the diagram. You can study these equations as well as about the diagram, right? Okay. Now I will move into the next point. Whenever you want to draw a point, you can draw a point on the pad, right? I will take a new sheet, right? Okay. I will take a point, then I will draw a point, right? You can see the algebraic window. So A, I can see the x coordinate as well as a y coordinate. B, x coordinate, y coordinate. C, x coordinate, y coordinate. Am I right? Like that, wherever you want, no, you can draw a point. Am I right? Okay. Next, I want to draw a point on an object. Is it clear? Right? What I will do, I will take an equation y is equal to x square. Right? So now I want to draw a point on this curve. Is it clear? What I will do? I will select point on the object. I will draw a point on the object. Is it clear? Right? Okay. So now I can move these points on the pad. Right? So this point move along with the curve. Right? So it is on the curve. Right? It is very beautiful. So it means whenever you want to study a curve at a particular point, is it clear? Right? So curve at this point, is it clear? Right? So x coordinate is 0.02, y coordinate is 0, right? So like that you can move. Now it is 0, 0. I hope it is visible in the algebraic window. All right? So it is very simple. It is very user friendly software. Okay. Now you can draw a point, right? So intersect. So you can draw two lines, or I will draw a line, right? Okay. So now we have two objects, this curve and this line. Now I want to intersect these 2 points. Where is the intersection point? So this is the intersection point. So I am going to intersect these 2 points. I will select intersect option. I will press both the objects. Okay. Now this is the intersection point, right? This M is the intersection point. Am I right? Okay. So M is the intersection point. You know the coordinates of M and N. Is it clear? It is automatically printed on printed on the algebraic window. Okay. So like that you can study all these things. All right. I will move into next. So you can draw a perpendicular line, parallel line. Is it clear? All right. You can draw a tangent, etc. Right. So whenever you want to draw a polygon, you can draw a polygon. Right? A regular polygon. Now it is asking you for other points, right? If you want, you can draw or type more points. Okay, right? Then you will get it. I will cancel. Like that, you can draw a polygon. Just you can select and drag, right? If you want to draw a circle, you can draw a circle, right? Circle with radius. You can mention the radius. I will type some number 4. It will draw a point with a circle. Like that, you can use all the menus, right? I wanted to show you one more thing, more important thing. I don't want to store, right? Okay. If I want to calculate angle, I am able to calculate angles, right? I will take 3 points. Okay, A, B, and one more point. If you want, you can join a line segment from A to B, A to C. Suppose if you want to calculate an angle, you can calculate A, B, C. What is the angle? 47.85 degree. Like that, you can calculate angle. And if you want to calculate length, you can calculate length, right, from these 2 points. If you want to calculate length from these two, I hope you will get length also. Like that, you can use all these information. If you want, you can calculate slope. I will show you later stage how you are going to calculate a slope, right? You can use these properties, right? So slider is an important, as I have mentioned. If you want to make an animation, in that case, I am going to use the slider button. Is it clear? Right? So whenever you want to type a text, you can type a text, right? What I have written here, right? Whatever you want, you can type. You can use all these things, right? You will come to know it is very user friendly. I will move into next point. Okay, I have increased and decreases of x-axis. So what is the next slide? Okay, the purpose of this, I have already verified all these you have observed, and I have calculated angle. So if you want, you can calculate sum of the angles, right? Say for example, if you want to calculate sum of the angles, I am going to join these 2 points. I have calculated this angle. Now I will calculate angle C. Okay. Now angle B will be calculated. Yes, I have calculated angle A, angle B, angle C. Now I want to verify when I want to add all the angles, what may be the sum of the angles, right? For that reason, I am going to use this keyboard because I want to type an alpha in input, alpha plus beta plus gamma, right, is equal to, right, what we are observing. Sum of 3 angles is equal to 180 degree. So like that, whenever you want to calculate angle, it is possible to calculate an angle. Am I right? Okay, I will move into next slide. Okay, it's over. Right? So how we are going to calculate derivative? It is very simple. Instead of typing, just I will copy this word. I will type in input command. So the derivative of x square. Okay. Now it is showing derivative of x square is 2x. Not only 2x. In the mathematics, what we will do, so derivative of a function, we will write derivative of x square, derivative of x cube, right? You will get the mathematical part. Here, derivative of x square is 2x along with the diagram. Here, you can draw the diagram of geometrical meaning of 2x is also present. This is clear. So this possibility is not available, or we cannot write derivative of each and every function's diagram cannot be written down in classroom. Is it clear? That is the advantage of GeoGebra. While finding the derivative of, suppose if you ask, what is the derivative of trigonometric functions? What is the derivative of not only simple trigonometric functions, you can take some complicated functions, right? You can find out the derivative, but we are unable to draw all the diagrams simultaneously. But in GeoGebra, when you calculate derivative of any function, you will get derivative of that function along with the diagram. That's why it plays an important role. Okay, so like that, you can try with all these commands, right? For the purpose of, I will take another example. Sin x. I will type derivative of sin x. Just I'll press enter key. Now it is showing it is unknown. It is giving an error, right? So because s was capital. No. Okay. Derivative of sin x is cos x, right? It is showing the derivative of sin x along with the diagram. Is it clear? Right? So like that you can try with other functions. I am not going to try. So derivative of sin x plus cos x, derivative of 10 sin x plus 20 cos x, derivative of exponential function e raised to x, derivative of sin 2x. How many times? 5 times. Suppose if you type sin 2x, comma 5, it will calculate derivative of this function. How many times? 5 times. Right? It means in general, derivative of function, comma n. Suppose if you want to calculate nth derivative, right? It is very simple. You can write down sin 2x, comma n. N means you can give any number, 10 times, 20 times, like that. It will calculate derivative of the given function. Am I right? Okay. I will move into the next slide because I want to show you many slides. Okay. To demonstrate integration and area, it is very important. Now, in PUC, we have calculated integration, right? Definite as well as indefinite integral. Here, I am going to demonstrate first a definite integral. Integration from A to B, f of x dx, right? So I hope you know the meaning of integration from A to B, f of x dx. What it means, area under the curves. They will give a curve. We want to calculate area under the given curve. How we are going to calculate? How we are going to calculate means we are already familiar with the mathematical steps, right? How we want to know the area diagrammatically. I am going to demonstrate the same thing diagrammatically, right? So I will take a function. What is the function? X square plus 3. I will take this function, right? So I will take a new function to avoid the confusions. I will not store, right? In input box, I will type a function x square, it should be x square, all right? I want to make it as an x square. Okay. X square plus 3. I have drawn the graph of the given function x square plus 3, right? So what they have mentioned, select the slider tool A. Select the slider tool called as A and B. I want to create 2 sliders, right? Just now I have shown, no, I am going to use a slider for animation where I want to write. Okay. So now it is showing the slider. I will take a number minus, minus 5 to 5. If you want, you can change. Time being, I will take minus 5 to 5. I want to create one more slider, namely B, right? So again, I will take minus 5 to 5. Is it clear? Okay. So as per the instructions, I will move. Okay, I have created 2 sliders and I have drawn a function. Then I will move into the next slide. Move the slider B to a value greater than A. Okay, it is correct, right? Now I want to type 2 points, namely a comma 0, b comma 0 in the input box. What I will do, I will copy and paste in GeoGebra. Okay. Yes. Now you are observing a point on x-axis, right? Similarly, I want to type b comma 0. Okay, I have created 2 points. Then I will back to slides. I have created A and B. What is the next instruction? Now I want to select the built-in function, namely integral, right? So in integral, I have to write f x of A, x of B. It means you want to take a point on the curve. Is it clear? So integral, I will not copy. I will type INTE integral. When I write INT, you can see the lots of commands, right? So I want to select this one, integral. So my function name is f. That's why I will write f. Is it clear? Then I want to type f of I want to write x of A. No, what I have written. I want to go back x of A, x of B. Is it clear? I will remove this one. Integral f x of point A. Okay. Point B. Yes, right? It is very simple and very interesting. Now you are observing area under the curve. What is the area? 2.83. I have not used chalkpiece and blackboard. Without using chalkpiece and blackboard, it is possible to calculate area under the curve, right? It is a fixed area. In case of a board, no, I cannot change immediately because I want to change the limits. Then I have to calculate once again. Then only I am able to change the answer. But here it is not like that, right? Now I am going to change the answer, right? So now you can see the area under the curve. Now the area is 20.29, right? Area is changing automatically when I am going to change the value of B, right? So now I am going to change the value of another point A, right? So you observe the value of the area is continuously changing, right? So area is 21.2035. Is it clear? Right? It is very beautiful and it is very interesting, right? So very easily I am able to demonstrate area under the curve. That is the beauty of GeoGebra. Am I right? Okay, I hope it is clear. Now I will move into next slide. I have demonstrated integration. Right? Okay. Now you want to calculate polynomials. Suppose you can type a command like this. I will copy and paste. I want to know what GeoGebra will do. I am going to remove all these things to avoid the confusions. I am not going to store. Okay. Right? What I have written, polynomial x minus 3 to the power 2. So it is expanding. I hope you will get the expansion along with the diagram. That's why it plays an important role. Not only expression, algebraic expression, you will get a geometrical meaning of this polynomial. Sorry. Okay. So like that, you can simplify. Is another command. Simplify x plus x plus x. Then I hope you will get the answer 3x. Simplify sin x by cos x. You may obtain answer tan x. simplify 2 into sin x into cos x, it will give sin 2x. Like that, you can use all these built-in commands, right? A polynomial is a built-in command, simplify is a built-in command. Just in input, if you type p, you'll get all the commands begin with p, right? In simplify, if you type yes, you'll get all the commands available with yes. Is it clear? Right? You can try afterwards. Okay. And another important thing is, say for example, I want to draw a diagram. I want to draw a diagram between a particular range, right? Say for example, someone want to draw the diagram in between -3 to +3. Is it possible? Yes, it is possible. So for example, I am going to use this built-in function, right? So this is the given function. I want to draw the diagram of this function in between -2 and 6. Is it possible? Yes, it is possible, right? So you may ask, why you want to draw in between -2 and 6 only? Not necessarily. You can give any number, right? You can draw the diagram of a given function in the given range. Is it clear? I will come to know, or we will come to know. Okay, in input box, I will type this function, right? Okay. Yes, right? So what is the range? -2 to 6. Now I want to verify whether the diagram between -2 and 6 or not. Right? Okay, you can verify. It is a -6, sorry, +6, -2 to +6. So like that, you can draw the given function between the given range. Is it clear? Okay. Now I will type two functions, right? Copy. I am going to paste in the GeoGebra. Yes, this is the first function. Right? Okay. X e to the power 2x. I want to type one more function. Name of the function is g of x. I am going to draw another function in GeoGebra. You may ask why you want to copy and paste. Not necessary, right? Here I have selected these two functions. That's why I am pasting, right? Otherwise, if you want, you can type any function. Okay, I have drawn, right? You are observing f of x and g of x in the algebraic window, and you are watching two diagrams. If you want, you can change the color of these curves, right? You can, along with the using mouse, you can press right button, right? Select settings, go for color. You can choose any color, right? Okay. Is it clear? Okay. So now if you want, you can add these two functions. I am going to add f plus g. Right? Okay. I have obtained sum of these two along with the diagram. That is important. I will remove first two graphs. Right? Okay. This is the combination of f and g. Right? Like that, if you want, you can subtract. You can subtract these two. Like that, you can calculate f plus g. If you want, you can multiply by 5, first function 5x plus g, or first function plus multiplication of second function. Not necessarily 5, you can multiply any number with this second function. So g minus f, or you can multiply both of the functions. All these these are the possibilities available in GeoGebra. Am I right? Okay. Sometimes it is essential to define a user-defined function. Is it clear? User-defined function means, say for example, I want to define a function. So function value is 0 when x is less than 0. Function value is 3 when x is greater than or equal to 3. Is it clear? So these things plays an important role. I think in the PUC, you have studied this type of functions in continuity. Is it clear? Whether function is continuous or whether function is increasing, decreasing, all these things plays an important role in engineering. Is it clear? That's why, so you must know how we are going to draw such a type of functions in a tool. or in particular in GeoGebra. Okay, I am going to write. So what we have written, construct a function f of x is equal to x when x is greater than 2. How I am going to write down in GeoGebra? F of x is equal to, if x is greater than 2 comma x, what it will do, I want to verify, right? I will copy and paste in GeoGebra. Okay, I will paste. I will remove previous diagram. Just a minute. I want to take a new one. Yes. Right? I want to draw a diagram f of x is equal to x. X is greater than 2. It means the diagram of x, right, should be present after 2. When it is less than 2, it should not write. That is the meaning, right? It means function is present after 2, right? It is not present before 2. It is just like a class. Your GeoGebra class will started at 11:30 AM onwards. Before 11:30, class was not started. It is like that, right? Okay. It's very interesting, right? So like that, you can define all these functions. Whenever you want to define this function, this can be written in GeoGebra. F of x is equal to, if x is less than 0, comma 0, 3. Is it clear? Or this can be defined in this form. I hope you can practice afterwards similar type of functions, right? Okay, construct a function exactly in the similar way. This can be write down in GeoGebra using this command, right? Similarly, it is also similar to previous one. All these slides are similar. That's why I am going to skip these slides. Construct a function. So whenever you want to define a sin x between 0 to pi, sin 2x between the limit pi to 2 pi, sin 3x when x is greater than 2 pi. How I am going to write down in case of GeoGebra? You want to write this statement, right? It is not necessary to remember all these statements. So these statements are available. So I will remove this diagram to avoid the confusions. Okay, in input box, I am going to type that command. Okay, right now you are observing sin x within the range, sin 2x in another range, sin 3x in third range. Is it clear? So along with the diagram, right? It is very simple and very interesting. Okay, so what I want to do, I have drawn the diagram like this, right? So whenever you want to change the color of a particular part, yes, it is possible to change the color. How you are going to change the color, right? So you want to type this statement. You can give the range, right? So in input box, you want to type, just I will type that statement. Okay, I have created the points. I have created the sections A to B, right? C, D, and E. Okay. Right? Suppose if you type like this, you can create the create the points A, B, C, D, E. Next, what I will do, I will type this function. Function, name of the function, x with a particular point, x with a particular point. See, I will copy this command and I will type in input box. Okay, now you can observe the color of the section A to C is different with the original color, right? So like that you can change the colors of a particular point of the curve. That can be done very easily by typing, right? And one more command is E to infinity. If you want, you can change the color from point E to infinity. E onwards. E to infinity means E onward. Yes, in input box. I will paste that command. Now you are observing the color E onwards is different. Is it clear? Right? So A to C is one color, C to D to E is original color, E onwards a different color. Like that, you can change the color of the curve. That can be changed. Right? Okay. Next next slide is in input box. Suppose if you type x square plus y square is equal to 4. You want to know what type of diagram I may be obtained from this equation. You can type any equation, not necessarily these equations, right? So just I want to show you I have identified some equations. You can type any equation. You'll get a circle, right? In the 2 dimensions. Suppose in 3 dimensions, if I type the same equation, what I want to obtain. I hope you are observing when you open the GeoGebra, you can see a graphing, geometry, 3D graphics. Now I will select the 3D graphics, right? I will paste the same equation once again. Now you are observing a 3-dimensional diagram. Am I right? So when I type an x square plus y square is equal to 4, so you will get a diagram like this, right? You will get a cylinder. So I can measure the volume of the cylinder. Is it clear? I can draw a particular point on the cylinder. Is it clear? Right? Upward direction as well as a downward direction. Negative part as well as a positive part. So I can show all these things to my students very easily. I cannot show this type of diagrams on the board. Is it possible? It is highly impossible. Is it clear? Right? That's why it is plays an important role. GeoGebra is a very important tool for mathematician. Am I right? Okay. Right. I will move into the next equation. So they have written x square plus y square plus z square is equal to 4. Okay. I will select this equation. I want to draw and one more equation, namely. Okay, I will remove this diagram. So now you can see the sphere x square plus y square, sorry, x square plus y square plus z square is equal to 4. All right. Okay. I want to change the equation. Whenever you want to change the equation, you may ask, sir, why you are written right hand side 4 only? I am not happy with 4. Can you change? Yes, I can change the number, right? You can observe the diagram. What is the change in the diagram? All right. Why is 6 only? Someone may ask, I don't like 6. I want 8. All right. So what is the change in the diagram? You can observe the diagram. Right. Someone may ask, why 8? I want to type 9. Yes, go ahead. Right. 9. Right. I will type 12. Right. Now you can see the changes in the diagram. Is it clear? So it means when I am going to increase 4 to 12, right, the size of the sphere is increasing, right? Size of the sphere is increasing. Is it clear? Okay. I will back to slides. I want to select one more important thing. Just observe this diagram. I have already shown derivatives and I have already shown, I think you want to calculate slope. I will show you how we are going to calculate slope. And I have already shown how you are going to draw a point on the curve, right? So this is the curve, any curve, right? On this curve, you can take a point. I have already shown, right? I think you are observing a small straight line or a segment. So now it is changing its color. Sometimes it is red, sometimes it is black, right? Is it clear? Right? It is changing the color. What is the meaning of that? So we can grasp lots of information from this diagram. Is it clear? Right? I have considered a particular function and we can draw the graph and we can draw a point on the curve. You can draw a tangent and it may move like this, right? I will move into the next slide. Lots of informations can be collected from one single picture, right? So at each point means point is moving on the curve. The derivative is the slope of a line that itself or that is tangent to the curve. Means we'll ask what is the geometrical meaning of a derivative. We'll say that slope of a tangent. Have you seen slope of a tangent? So far, you have studied differentiation in PUC. Have you seen the meaning of the derivative is you have studied differentiation. You have calculated derivative of so many functions, right? Have you seen derivative meaning? No, right? Means geometrical meaning. We will say that the slope of the tangent, right? What we are observing on the screen, right? The line is always tangent to the blue curve. Its slope is the derivative. It means derivative is positive. Sometimes derivative may be positive, derivative may be negative, derivative may be 0. That's clear, right? So I will give y is equal to x square. I will ask you to find the derivative of x square. How many times? 3 times. You will get 0. That's clear. Sometimes derivative may be positive, derivative may be negative, derivative may be 0. All these things can be observed in one single diagram, what we have observed in the previous slide. That's clear. I want to go back once again. You can see the color, right? Sometimes it is positive, sometimes it is negative, sometimes it is 0. Is it clear? Right? Green, red, black. Green, red, black. Green, red, black. Is it clear what we are observing? Derivative is positive. Where green? Green iddaga derivative positive irtada. Red iddaga negative irtada. So 0 iddaga, black iddaga 0 irtada. Is it clear? So you can observe all these things. Okay. I will move into the next slide. Sir, continue ಮಾಡಬಹುದಾ ನಾನು?
Yes, sir. Yes, sir.
Yes.
Another 10 minutes, sir.
Okay. I'll move. Right. So you can see 3 planes, right? 3 planes. So planes means in mathematics we are going to write down the equations like this, right? So one equation represents one plane, another equation represents another plane, right? So all the 3 planes, right? I am going to draw these planes in GeoGebra, right? So when they are intersecting at a particular point, then we can say that you will get the solution. Otherwise, no, you will not get the solution. Am I right? Okay. So here I am observing. So just when you type one equation, no, you will get one plane. I will show you. One day equation ತೋರಿಸ್ತಾನೆ. Copy and paste. Right? Okay. Now you are observing a plane. Right? Suppose if you type one more equation, copy and paste. Right? Now you are observing this one more plane. All right. I will copy and paste. Yes. Now it is showing 3 planes intersecting at a point. That's why you will get a unique solution, right? If they are not intersecting, then you can say that it is inconsistent. Is it clear? Consistent and inconsistent, you have said last year, right? Sometimes you will get infinite solutions. You can draw 3 planes along with this line, what I am showing. So along with this line, you will get infinite solutions. Sometimes you can move the planes, right? So okay, so you can calculate slope. Just you can type a particular curve right? You can take a point on the curve, draw a tangent, right? Then you will get slope of a curve. I will select new. I will take a very simple example, x square yes, take any point, right? Tangent, you can search the tangents as tangent. I will select curve and point. You will get a tangent, right? Okay. Just now I have shown you can move like this along with the curve. Now I want to calculate a slope. What is the slope? Select this slope, press curve, point. Yeah, right? So slope is 1.86. Like that, you can calculate slope. All right. Next slide. Right. So GeoGebra activity can be shared. Right. So for example, now I am conducting GeoGebra activity in a classroom. All my students are not in the classroom. They are in different places. That's clear. I can share all these activities to your place using Google Classroom. That's clear, right? It is also possible. In polar coordinates, you are going to define a point. So you may ask why you want to study polar coordinates, right? For example, a radar detects two aeroplanes at the same altitude. Their polar coordinates are 8 miles, 110 degree, 5 miles and 15 degree. It means two aeroplanes are moving towards the airport. Now I want to find out a distance between two planes. How I am going to find out, or how this problem can be solved using GeoGebra, right? So this problem can be solved GeoGebra very easily, right? Okay. So one plane A, another plane B. I can find out the distance between A and B. I have already shown you how you are going to calculate. All right. Next one is you can create an points P2 and P1. All right. You can create 2 points using a GeoGebra. All right. Okay. You can create like this, or you can create so many points, right? Like this. So like that, I can define a polar point, 3 different polar points, right? So what is your conclusion? I want to ask you, suppose I have defined 1 comma 315 degree, 1 comma minus 45 degree, 1 comma 675 degree, right? So you may say that all these points represents different, but so all the points are same. Is it clear? Here, this point is equal to second point is equal to third point. These things can be shown in GeoGebra, right? So due to the time, and I am unable to create all these things, right? You can define 2 comma pi by 6 minus 2 comma minus pi by 6 minus 2 comma 7 pi by 6. All these are same, right? It means I can create a particular point infinitely many ways, right? So we are going to use r and theta now. When r is less than 0, I can create a graph. When r is less than 0, right? Or you may ask, what is the graph of 3 sin x? I have converted Cartesian to polar form. Now I have obtained an equation r is equal to 3 sin x. Now I will come to know what is the diagram of 3 sin x. You will get a circle, right? You will get a circle. Similarly, 3 cos x, diagram of 3 cos x is a circle, right? 3 secant x, 1 plus 2 cos x. I am going to convert Cartesian to polar form, and I can obtain this type of equations, right? So all these activities are there. Due to shortage of time, I am unable to show you. So in general, you can create an slider D and K. You can vary with the numbers, right? Then you will get various diagrams, and you can calculate sine 90 is equal to what is the number cos 90 or sine of some angle. It is possible to show all these things, right? Conversion. I am going to convert polar to Cartesian, Cartesian to polar. So those things can be demonstrated. All right. So finally, I will move into some differential equations. Okay. I want to show you an differential equation. It is an important first order differential equation. We will call it as an initial value problem, right? Okay. So they will give an equation like this: dy by dx is equal to y of 0 is equal to 3, right? What it means? I will find out the solution, right? So you will get a solution curve like this. Y of 0 is equal to 3 means the solution curve passes through the point 0, 3. That is the meaning, right? Now you are observing a point A 0, 3. Our solution curve passes through the point 0, 3, right? Green color curve is the general solution. Red color curve is the particular solution, right? I wanted to demonstrate one more differential equation. Okay, here they are given second order differential equation y double prime minus y is equal to 0. They have given two conditions: y of 0 is equal to 4, y single prime of 0 is equal to -2. So what is the meaning of this equation? We can grasp a lot of things from this equation. 0, 4. Our solution curve passes through the 0, 4. Yes, passes through the 0, 4. They have given one more equation: y single prime of 0 is equal to -2. It means at this point, suppose if you calculate slope is -2, right? And this tangent crosses to the point 2. I will come to know, right, from this information only. So these things can be grasped, right? So like that, I have prepared some more differential equations. Due to shortage of time, I am unable to show you, right? So I can demonstrate single integration. You have studied single integration in PUC second year, means indefinite integral. Geometrical meaning of indefinite integral. So when you have used textbooks, in front page they have drawn this diagram, right? So you can draw a curve, right? So you will get a various curves. C can be replaced by 1, 2, 3. Like that, you will get a family of curve. So you can calculate slope. Slope must be same at each and every point, right? So just a minute. Yes, I am going to change the curve, right? You observe the slope. Slope remains remains the same. That is the meaning of a definite integral, right? Curve tracings. So Newton-Raphson method. So I am unable to show you. Okay, I will conclude my speech with this statement: when teachers use technology strategically, they can provide a greater access to mathematics for all students. Thank you.
Thank you, sir.
I take this opportunity to thank Professor Rampure sir, Principal KLECET Chikodi, Mr. Sachin Makalki, HOD, and his team, Mathematics Department, KLECET Chikodi. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Sir has explained nicely that how we can use GeoGebra, which is cloud platform of algebra and geometry. Also, sir has explained with a hands-on training using number of examples. Once again, thank you so much, sir, for the wonderful session on GeoGebra, which helps our faculty and students to understand how exactly the equations appears geometrically. Thank you, sir.
Excuse me, sir.
Hello.
Excuse me, sir.
Huh.
Sir, my name is Rupali.
Okay.
Sir, even I have done engineering, but I want to ask you, sir, this GeoGebra, how can we use the grades first to 10th also, sir?
Can you repeat? Grades?
Yes, sir. Now, see, you told that how we can use the GeoGebra in the engineering.
Okay.
Okay. So I want to ask that the GeoGebra, how we can use for standard first to 10th in a mathematics?
First standard to 10th standard.
Yes, sir.
Okay. No, you can. I think we have studied Pythagoras, no? Pythagoras theorem.
Yes, sir.
No, we can demonstrate Pythagoras theorem in GeoGebra. I think nowadays in all schools and colleges, GeoGebra is using for a primary
Yes.
section throughout the world, not only in India. Actually, I have planned, or I means our PUC department planned to introduce GeoGebra in their curriculum 3-4 years back. In that year, I have trained 1100 PU teachers for GeoGebra, right? So like that, we can use in each and every concept. GeoGebra can be used to demonstrate mathematical concepts. You can take any concept. In that case, I can say that it will helpful for the students to understand the mathematical concepts very easily.
Okay, sir. So, and it's my request to you for can you make a one more session for the other grades also, sir?
Definitely, I am ready. I have not shown you anything. It is an just introduction. Whatever I have shown you, no, it is an
Yes, sir.
introduction to the GeoGebra. Is it clear?
Yes.
Right? I
Yes,
have
sir.
not just I have due to the time. No, time is very
Yes.
less. That's why I am unable to show you lots of
Okay, sir.
differential equations. Laplace transforms can be demonstrated. Fourier series can be demonstrated using GeoGebra. I have not shown you all these things, right? And
Okay,
for
sir.
example, suppose if you want to approximate a particular function, right? You may ask, how do you get sine 90 is equal to 1? Can you tell me? Yes, I am ready to prove you with the help of GeoGebra. Such type of functions can be approximated. Means those things can be demonstrated using GeoGebra, right? If you are ready to listen, I am ready at any time, right? You can ask
Okay, sir. Okay, sir.
your college authorities.
Okay, sir. Thank you so much, sir. It was a nice session actually. So we were not aware about such softwares, but you helped us a lot to learn about GeoGebra, and I hope it will be useful for all the grades, not only for the engineering, sir.
Yes.
Thank you so much, sir.
Okay. Welcome.
Participants, you have any questions? Please do ask.
Sir, there is a question in chat box. How to hide the objects in GeoGebra?
How to hide?
Yes, Sana Patait, she has asked one question. How to hide the objects in GeoGebra?
No, we are trying to draw the diagrams using GeoGebra. Right? Why you want to hide, I don't know. Okay, I will tell you, I can hide, right? And I have shown some examples. Diagrams can be drawn between -2 to +2, right? Remaining part is not visible. Right? Yes. Diagrams can be drawn between -2 to +2. Other part is removed. Yes, sir.
Thank you so much.
Okay. Is there any other questions?
You have any? Please ask. Otherwise, type in chat box. Thank you so much, sir. Now, I would like to request our beloved principal, Dr. Prasad Rampure, to present a presidential remark.
A very good afternoon to everybody. I hope I am audible.
Yes.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Yeah. Good afternoon, everybody. Today's resource person, Dr. S.S. Benchalli, sir, Faculty of Mathematics, dear participants, and all my student friends. Happy National Mathematics Day 2020. Today, Dr. Benchalli, sir, has explained practically how to use GeoGebra application for better understanding of the concepts in mathematics. Particularly, Sir has focused on how engineering mathematics concepts look in GeoGebra. In fact, it is very user-friendly, freely available online software. I request all the participants to install and make best use of this software. I am very much happy that our students are actively involved in making mathematical models. In fact, last year, some of the students from college, in fact, as a part of students from KLE International School, in fact, they had come there, and from there they had come to this particular college, and our students had made some models and have explained to them. So our involvement of students in this college is highly appreciable. And in fact, now whatever students have come now this time, I hope they will also be involved very much. In terms of results also, our students are doing extremely well. In fact, I have seen during the introduction, one of our madam has already told about the marks. So I don't think so I should talk more about it. There are a lot of students who have got more than 90 marks, and in fact 3 of the students have got 100%. To talk about mathematics and mathematician, people often wonder what relevance mathematicians serve today. In a modern world, maths such as applied mathematics is not only relevant, it is crucial. Applied mathematics is the branch of mathematics that are involved in the study of physical, biological, or sociological world. The idea of applied math is to create a group of methods that solve problems in science. Modern areas of applied math include mathematics physics, mathematics, control theory, not only aerospace engineer, and maths finance also. Applied mathematics requires expertise in many areas of maths and science, physical intuition, common sense, and collaboration. The common approach in applied mathematics is to build a mathematical model of phenomenon, solve the mathematical model, and develop recommendations for performance improvement. While not necessary and opposite to applied mathematics, pure mathematics is driven by abstract problems rather than real world problems. Much of what's pursued by pure mathematician can have their roots in concrete physical problem, but a deeper understanding of these phenomena brings about problems and technicalities. These abstract problems and technicalities are what pure mathematics attempt to solve. And these attempts have led to major discoveries of mankind. And the universal turning machine, which began as an abstract idea, later laid the groundwork for the development of modern computer. Pure mathematics is abstract and based in theory, and is thus not constrained by the limitation of the physical world. According to one pure mathematician proves theorems, and applied mathematics constructs theories. Pure and applied are not mutually exclusive, but they are rooted in different areas of maths and problem solving. Though the complex maths involves in pure and applied mathematics is beyond the understanding of most average citizen. The solutions developed from processes have affected and improved the lives of all. Once again, I congratulate all the members for organizing this webinar, and I also thank Professor, who has spared time to be involved in our college. I think, Sir Benchalli, sir, I personally request you to come over to this college once, and let us have some other programs also, wherein this is a webinar, but things have changed now. Slowly, physically, everybody will be coming. So as a maths day, we have celebrated, but for the benefit of our students, in fact, one of the student was asking about the other aspects also. So I assure all my students that sir will come once physically to our college, and whatever clarity has to be there, he will be doing it physically. So for the benefit of my student, I request Benchalli sir to come to our college once the situation becomes normal, and very soon it is going to become normal. So I once again thank you, Benchalli sir, and all my students who have joined the webinar. Make the best use of this webinar, and whatever difficulty is there, you can always ask, sir. Thank you.
Thank you very much, sir.
Thank
It is
you,
also my institute. I have started my career from KLE Society only. I have started my career from PC Job in Science College, sir.
Okay, sir. Okay.
I'm very happy to visit your college, sir.
Yes, sir. Yes.
Thank you very much, sir.
Thank you, sir, for your kind words of motivation. Now, to conclude for today, I request Dr. Arvind Deshi, Department of Mathematics, to present a vote of thanks.
Good afternoon, everyone. Wish you all happy National Mathematics Day. I am honored and lucky to have an opportunity to propose a vote of thanks on this special day. First of all, I would like to thank today's resource person, Dr. S.S. Benchalli, who have readily accepted our invitation and delivered the special lecture on GeoGebra and its application. The session was very nice, sir, and it is useful to all the participants who have attended. Thank you, sir. Now, I thank the today's webinar president or principal, sir, Dr. Prasad Rampure, who is always encouraged us to conduct such events. Thank you, sir. Next, I would like to thank the academic coordinator, first year coordinators, and all HODs and all my dear colleagues. Thank you, sir. Also, I thank the technical staff who helped to conduct this event. Lastly, I must not forget to thank all the participants without whom this would not be successful. Thank you once again for making this webinar successful. Thank you all.
Thank you, sir.
So I request all the first year students to continue with your regular class. 4th hour class is going to start soon. So you can join to the, as per the timetable, you join to the 4th hour of the today's class. Thank you one and all.
Thank you so much, sir.
Thank you.